Hey guys, welcome back to the Meck restoration project. As I've been going through and swapping in the rebuilt capacitors, I've been periodically powering this up to make sure it's still working. And it has been, but there's one problem that remains. It's been here pretty much since the beginning, and that is the focus control that focuses the electron beam on the face of the CRT. I have it at one extreme of the control. If I go and back off, the focus gets really fuzzy. And even at that one extreme, it's not quite as sharp as it should be. And ideally, I would like the sweet spot to be in the middle of the control range and not at one extreme. Well, how is that control set up? Well, there's a whole bunch of resistors here. So the ways electrostatic CRTs work is there's an accelerating anode that will be the highest potential. It's around 5,000 volts. The focus control is going to be around 2,000. So to get that, they take the output of the high voltage supply and they go through a whole bunch of resistors, focus control, and then a couple more resistors. So this range is going to be probably 1.5 to 2.5 thousand volts. So those resistors have probably drifted off value. And if you're wondering why the heck do they use a 4.7, a 4.7, a 3.9, a 3.9 instead of just one like 15 meg resistor. These resistors have a voltage rating. If you exceed that, the material inside the resistor starts breaking down. For a 2-watt resistor, which is what they use, that breakdown voltage is 750. A 1-watt resistor is typically 500 and a half-watt resistor is 350. At the time, there were no high voltage resistors readily available, I imagine. Even today, they're specialty items. So they strung a bunch of these in series. However, if you do the math on that and add all those resistors up and figure out the current and find the drop across each resistor, I wouldn't be surprised if some of them are at or somewhat over 750, which would speed up the demise of these resistors, I imagine. I have certainly tested some in these sets that were way off or tested open. Well, anyways, let's see what we get. So here's one that should be 3.9, and we have 5. That's 10%. So 10% of 3.9 is 0.39, so it should be plus or minus that. Let's just round it up to 4 meg, and let's say 10% is 0.4, so 4.4. If it's less than 4.4, it would still be within tolerance, basically. And we're at 5, so we're over spec. This should also be 3.9 meg, 10%, way over 4.4. Here's a 4.7 at 20%, so that could be roughly 5.6 meg, would be within 20%. Just at the limit. And this is also 4.7, measuring about 6, slightly over. Now they're all high, so if you figure they're all high, that's really going to throw things off. So they're all right at the edge of their tolerance and they're all on the high side. And then the focus pot itself is a bit lower than it should be. Oh, I don't think I've showed you that. It should be 5 meg. It's measuring about 4. Or 4.7. So everything's off a little bit. And I think if you add up all those things being off a little bit, it adds up to everything being off a lot. Again, I do have a small supply of new old stock 2-watt resistors. I only have 3 of the 4.7s, and I know they've all drifted high. Carbon cap resistors just sitting around, not being used, drift off value and they drift high. It's the nature of the material they're made out of. So 5.1, it's high, but it's better than the one that's in there, which is about 6.1. So I'll use it. It's been some have suggested, well, hey, take maybe I've got a 3.9 that's drifted high now. It's about 4.7. Change the markings on it and make it a 4.7. Yeah, that's a possibility. But I've also been thinking, I must have made millions of these back in the day. I mean, I've got some new old stock ones. I'll go buy some. Sure. Good luck. Tube-based audio amps are very popular to restore, to rebuild, or to make new ones from scratch, and they often use 2-watt power resistors, and people like to use carbon comp because they want to make it look authentic and old school, and maybe they sound better. I don't know. But the effect is it's driven up the cost of these. Turns out there's actually a very simple solution to this issue, in this particular instance anyways. If you add up these 4 resistors, the 2 4.7s, the 2 3.9s, you get 17.2 mega ohms. What do you suppose I get if I go across the 2 4.7s and one of the 3.9s? I get about 17.8. That's close enough. I'm just going to short out one of the 3.9s. And let us see what effect that has on the focus. Yeah, that will put more voltage strain on the 3 remaining resistors. That is true. I will go through and do the math and see, and if they're way over 750, then I may rethink this, and I'll go back to, maybe I'll use some 2.7s for the 3.9s, because all my 3.9s are 4.4 or higher, all my 4.7s are high, so if I put in 4 new resistors that are all at or slightly over their spec, I fear I may still have an issue, because on the other side of that pot, the 2 3.3s are within spec. So I really just need to drop this resistance down. Let's power up the set and see what effect that had. I shorted out the 3.9 on the left here, and I realized I don't have to do the math. I can just actually measure the voltage across each of these resistors. It's coming to life. There we go. Reception. Let's see. A little hard to see when it's up on the stand. Let's see how the focus is now. Yeah. It's not quite in the middle, but it's definitely not at one extreme anymore. It's about 1/3 of the way from one end. So that definitely is an improvement. Not perfect, but better. Now let's see what kind of voltage we've got across the resistors. Alrighty. Be a little careful here. We do have some high voltage. Okay, 560 across the 3.9. Maybe a bit more across the 4.7. 610, okay, we're within spec. And 600, alright. I think I could leave it like this, and we'd be okay. Well, I suppose it is a hack of sorts, but I think it makes a lot more sense than being more intrusive. So what do I have left? I need to restuff these caps and install them. I have a few of the wax to restuff, and then let's go about trying to do these axial electrolytics. One last item to address. That is the axial electrolytics with the paper cardboard sleeve. I've done a little bit of practicing. I finished one of them so far. I think I'll do a little bit better on the next one. So the challenge is to get the insides out. They're in a cardboard tube and they knurl over the ends. To get them out, you got to unknurl one of the ends, and it ends up looking a little ugly. This will look a little better once the glue dries. It'll dry clear. Then I can maybe touch it up with some orange paint. So I'll break it down for you a little bit. Here's one of them undone. So one thing, we can break off this crud that's oozed out. It is water soluble. Once I get this apart, it's not really coming off. I'll wash it off once I get this open. Open up the negative end. That's where they must have done it originally, because it's far more securely crimped on the positive end. You could just use your finger. It's just barely crimped over. Try to be as neat as you can so you don't tear it. The paper tends to be pretty dried out and fragile. And this one was kind of already damaged to begin with, so yeah. Now you don't have to get it all the way, because you're going to push from this side and it's going to come out that end. Like so. We'll flare out that end. Assistance to get this out all the way. And there we go. So we'll reuse that. Now we're left with this. We want to get the insides out. How do I do that? I cut them open. Just with a mini hacksaw. It's really thin aluminum. It's really, really easy to cut through. Sure, if you have a pipe cutter, absolutely use it. But doing this probably takes me less than a minute to go all the way around. And I'm already through quite thin. So I just finished doing this one, and once you cut through it, the ends pull apart. You're left with this inside. If you don't want to touch it, you can grab a napkin or something and get it up in that, and it just pulls apart. You can dispose of that, and then wash out this with some warm water. You know, get a Q-tip or an old toothbrush down in there and clean out everything really good. Alright, a little bit of warm water, flushed everything right out. There's where the pressure of the old cap deteriorating pushed out the seal. Nothing we can do about that. What we can do though is pick out the little bits of stuff remaining inside. There's some foil from where the old cap attached. A little bit of plastic insulation. We'll just get everything out. So we're just left with an aluminum shell. Alright, and same on this one. Some plastic insulator. Now this is all fit together with rivets and pressure, because it's all aluminum and you can't really solder to it. So back then everything was kind of pressed and stamped together. Alright, so what are we going to do with this? Well, we're going to put the new cap. Well, if I had to do this again, I would have taken these, I would have left the full lead length on there so I could reuse the leads. But I didn't, so I just have little stubs left, so we'll just clip those off because we can't really make any use of them. And instead we're going to drill some little holes to run our new leads through. You had two choices. You could go right down the center, or you could make a little hole right next to where the old lead was. Like I said, I've already practiced, so on the positive end, which is this one, it's insulated from the negative can, I went right down the middle. For the negative side, I put a tiny hole right next to where that old lead came through. This press fit rivet's pretty thick, and it's a little hard to drill through that. And again, I'll use my pin vise. This one's really easy to do. This aluminum, again, is quite thin. Of course, you could use a Dremel or something. And that's it. I want to make as small as hole as possible, so I have a, I think it's a 1/32 inch drill bit. Just a tiny hole right next to where the old lead came out. Now for my new caps, I have some Axial lead electrolytics. Probably enough room inside you could use radial lead and just wrap an extension lead around, but I chose to go with these. Now, if these were big enough, maybe if I'd gotten a higher voltage rating, you might be able to just put them right inside. Or you could wrap electrical tape around this and make it fat enough that it would actually sit securely inside. And I suppose you could fill it up with hot glue or something if you wanted to. You don't have to reuse these aluminum shells, but that's what I've been doing. So for the negative side, because I drilled that hole off center, I want to kink the lead over a little bit. And I can run it through that hole, and like so. And for the positive side, we'll go right down the middle, then we'll slide these down. Now everything will be kind of flopping around, and you could leave it like that and just put it back in the cardboard tube. But a little bit of hot glue or some type of filler material to hold it in place would be a good idea. You can't solder that. This is a tin steel lead or copper, and that's aluminum. And you're not going to be able to solder those two together very well. And you can also epoxy it or JB weld or something like that too. Now for the other end, that takes a little bit more effort. It's a little bit thicker material, but same idea. We're just going to drill right down the center. Something else you can do, you may not be able to solder this aluminum to this steel, but what you can do is put a solder blob on the lead, which will keep it from falling through, kind of hold it in place. There's also the little stub of the old lead, which I may be able to solder this to. Alright. That's not going to go anywhere. Okay, I want to get it kind of centered in there. I don't want to completely flood this because there could be some internal heating. Caps do have some internal resistance, and if there's a lot of ripple current, that cap could get a little bit warm. We want to leave some air in there. Alright, just put a few dabs around the outside so it doesn't go anywhere. I'll get a little around this top piece to move fast so it doesn't set up before I can get the cap down in there. Could always hit it with a heat gun if I needed to kind of get that glue warm again. Yeah, a little oozed out. That's no big deal. We can clean that up afterwards. Alright, that's the basic idea. Just clean off that excess glue. Alright, that actually worked pretty well. Now, take a cardboard tube and go positive end in first. And then this is so that paper starts flaking away and breaking away, and that's the hardest part in this whole process I've found, is to get this back in without completely annihilating that end. Alright, there. Now run some Eileen's tacky glue around that seam and start folding it and knurling it back over, and that's it. So I'm just running a bead all around, and yeah, it gets kind of messy, kind of sloppy. So work it into all the paper fibers, and then start trying to bend it back over. Glue dries clear, so I'm not too concerned about being a little messy with it. Also, I can take a swab, get the end a little bit wet, and clean up some of the excess. And that's it. If any of you have any tips, tricks, or suggestions, please let me know, because that is the best I know how to do this. Well, it was a bit challenging, but this side is finally done. Everything from the front controls all the way back. That's where I left off. One cap left here, and then we have this side. I think this is a good time to pause and flip the chassis down and see how the set is working. I ended up replacing 5 or 6 resistors, and of course reinstalled the rebuilt caps. So I'm curious to see what the performance is like now. One, I'll show you how the focus control works better now, and with the changes to those resistors, I'm hoping that the vertical and horizontal scan circuits work better now. So if I go all the way to one end, it's a little fuzzy, and it gets sharp, really sharp, and then it gets blurry again. So it's just good right about there. And the horizontal linearity is messed up. That's that trimmer cap down below. It's kind of squished on the right and stretched on the left. I finished checking all the resistors on this side, and I marked all the ones that were, say, 30% off or more with a white dot. And unfortunately, there are quite a few, including every 150 ohm resistor down this line. There's 5 here, there's 1 more there, and a bunch of other values that are off, including the 18 ohm resistor off the selenium rectifier. It's measuring about 29 ohms. And at first I thought, oh, well, I better replace that. That will boost the B plus and make things work better. Then I remembered, wait a minute. I installed a silicon rectifier, which is more efficient than the selenium. So to get B plus to be the same, I would actually want to increase this anyways. So we're going to leave that alone, and we'll get back to it when the set is all done being worked on, and we'll check that voltage, and we will adjust this resistor if needed. Now, something else I wanted to point out, if you ever work on this chassis or the other sets that used this type of chassis, be very, very, very careful when working in this area, because these IF transformers, I guess to save money, they are completely unencased. So the primary and secondary are these really little fine hair-like wires coming off and going right from the coil to the tube socket. Normally, these fine wires would be contained inside of, say, an aluminum box, and there'd be some sturdy lugs coming out the bottom, and then there'd be a wire running to the tube socket. But no, these are just bare, naked coils. It's so easy to brush against those wires and snap them off. Just a warning to you if you ever work on such a set. I've seen some others, like the Motorola's, do that to some extent, but the wires are not quite this thin. I was a little taken aback when I saw that, and I almost snapped one or two of them off, so I gotta be very cognizant of that. Hey, one good thing. I looked at the alignment instructions for this. They are the simplest alignment instructions I have ever seen for a television. There's basically two steps. This third step is if you do with a visual sweep generator. This first step is if you use a fixed RF. So you're either going to do steps 1 and 2 or step 3, not steps 1, 2, 3. So let's assume we just did the first two. That's it. There are just 2 frequencies and there are 4 coils for the entire IF response. Is a really cheap way to do the wide bandwidth IF that a TV requires, where you just have 2 peaks and a valley in between, which is up to 20% dip in the middle. This needs to be ideally around 4 megahertz or so wide. They just pick 2 peak points and there'll just be a valley in between the sum of the 2 response curves. The better way to do it is you would have all 4 coils tuned to a slightly different frequency, so when you add them all up you get a flat top plateau here, but that's not what they did, again, to save money. So if we do the alignment, that's it. 4 coils, VTVM, inject a signal, 2 different frequencies, that's it. And then the audio is similarly quite simple, just 2 steps. 2 coils to peak to 4.5 megahertz, and then the typical ratio detector, you tweak it for a 0 reading in between a peak and a valley. So we will get to that. Getting ahead of myself, but I was kind of amused when I looked through the service info and saw how dead simple it was to do. No DC bias voltage, no modifications, no special test harness, not multiple frequencies, just 2 frequencies, 1 injection point, peak 4 coils, that's it. I'm making steady progress on this side of the chassis. It turns out it's not that bad to replace these resistors because a number of them share a lug in common with the capacitors that I'm also working on. So killing 2 birds with 1 stone. Another bit of good news is I just got a box of parts from Just Radios. They are up north. I believe they're based in Canada, but this was shipped from Niagara Falls, New York. And shipping was reasonable, so I suspect he's crossing the border to actually do the shipping. Actually, it's free shipping on orders over 100, so I made sure to get more than $100 worth of parts. And what did I get? Why did I want to order from Just Radios? Because he has a good stock of Axial capacitors. So I replenished my supply of the Axial type film capacitors. Better yet, he has the high voltage Axial capacitors. I'd heard a rumor that he was out of stock, so I was a little bit nervous, but no, he has them. But what's interesting is they're a different brand that I haven't seen before. In the past, I've always gotten ASC high voltage capacitors, like so. And I was primarily getting them from Allied Electronics. Well, they've been out of stock for ages, and it seems like they aren't going to be getting any more in, well, maybe ever. So I feared that maybe ASC was getting out of the business, but these are SHV branded. And I Googled them, and it's Chinese capacitor brand. They seem to be specializing in high voltage caps. There is so much going on behind the scenes you guys don't know about. I am bursting with news and announcements, and, well, I'm trying to keep focused. One, you can probably tell from my voice, I'm feeling better. Thankfully, probably back to 75–80%. Thank you for all the well wishes. And I really appreciate it. And for those of you who are still recuperating, I hope you make a rapid recovery. It's no fun. Okay, what am I looking at? I searched around and found a supplier of cardboard tubes that are the closest I could find to the originals, which were about 1.5 inch inner diameter. For some reason, that's just not a popular size now. What is a popular size is 1.57 inches, or some sellers say 1.6 inches. That might translate to something metric that makes more sense, but see, it's slightly, well, that's exaggerating because it's actually split there. Let me try to get that back. This is thicker. And so the inner diameters are actually pretty darn close. I don't know if that 1.57 is the inner or outer diameter, to be honest. What I do know is if I put this around the remains of the old base, it's almost a perfect fit. There's a little bit of slack, a little bit of hot glue, a little electrical tape, or just something to make up a little bit more to fill in the gap. Just a little bit, they'll be perfect. Colors close. The diagonal spiraling is about the same angle. Yes, this is getting crazy obsessive. What am I getting at? All right, I am still going to attempt to salvage these old covers, but if I can't, I'll try using these, and I will probably use them on future projects as well. There's some RCA sets, 721 I want to get back to, where I, same problem. I ended up destroying the cardboard covers in the process. Now that set's a little different, as are most sets, because on most sets these cardboard covers are black, or some color. So I've seen some silver, some goldish, but generally they're black. Sometimes the values are printed, sometimes they're stamped into the cardboard. I'm pretty sure this is the first time I've ever seen it where it's just raw cardboard. Now if I do have to make new ones, what do I need to do? If I really want to get it perfect, I need to cut the height down a little bit. Okay, that's fairly easy. But I got to seal the end off. The originals, they cut out a disc, and then they fold it over the top a little bit. They knurled it over somehow. There's probably some device lost to history that knurls over the end of a cardboard tube. I did a brief Google search and find absolutely nothing. This is thicker though. I think this would be pretty hard to fold over. But what I've done in the past, I did do this once before and I ended up making tubes from scratch. I actually got some craft paper and glue and made a wooden form, and I wrapped it around and glued it up. And for that, what I did was I cut a disc and I kind of glued it in place and just sort of built up around the edge with some glue. I didn't try to fold over the edge, so I could do that too. Yes, this is getting, a little obsessive. But partly, again, I'm doing this just to show you, if you want to attempt this, this is what you might run into. I'm not suggesting you all go out and do this. And as far as this goes, if you watch, I did a Hallicrafters 506 7 years ago or something. 7-inch electrostatic set, rather different design, but I also restuffed all the caps in that one. And some of them were missing, and I had to fabricate new cardboard caps from scratch. And those, I made some cardboard tubes up. I painted them to match the ones that were still there. And I printed water slide decal. I might still have some of that paper on hand, otherwise I can order some. But I can't, so it's clear plastic film that's got some special backing, and it's put onto a piece of paper that you can run through a printer. Then you can cut out your printed area, soak it in water, and it slides off the backing. If you have built models with water slide decals, I'm sure you're familiar with that. And then you can slide it onto your part, let it dry a bit, and then clear coat it. Now, if I try to do a water slide decal on raw cardboard, it's going to be a disaster. The water's going to soak into the cardboard, it's going to swell up, it's going to destroy the decal. I would have to clear coat this or seal this with something, water slide decal, and then clear coat it again. Yes, crazy amount of work. But it's not like these cost a whole lot, and I just, for a few bucks. Let's see what we can do. Back to this. Because there's a lot of work that still needs to be done, a lot of resistors need to be clipped out, I'm wary of doing all of that and then trying to power it up. I'm going to do it in a few stages. I want to do a little bit more work and then we're going to power this up. Now something else, when I powered it up a little while ago, the horizontal linearity looked horrible. And I replaced those two plate resistors on the horizontal output tube. And I thought, oh, that must have really affected things. And I'm not saying it didn't. But just now I was editing the next installment I'm about to upload. Right after I rebuilt the high voltage power supply, and I was tweaking that and increasing the voltage, I didn't notice it at the time, but the horizontal linearity on that was pretty bad too. So I think that horizontal linearity has been bad for a while. I don't think it's the result directly of me replacing these two resistors. I think it's a lot more likely it has to do with me, when I took out the tubes to test them and put them back in, I didn't put them all back in the same spot, and I replaced one of them at least with a new tube because one section had died. So I think some stuff needs to be adjusted. There is a variable capacitor here, horizontal linearity. I don't see it mentioned in the service info. They don't mention how to adjust it. Obviously, we can just try it with a test pattern. I wouldn't have expected it to have that much of an effect, but I hope it does because things are pretty bad. I also need to make sure I do have the correct high voltage, and then I have also a width control. So in other words, we have a few things we need to adjust, or that we can adjust to get that picture looking right. That's making me a little nervous now, because the rest of the stuff that work to be done over here is like on the IF. That might affect the gain or the contrast. It has nothing to do with the sweep circuitry. So nothing I do over here is going to change that linearity at all. So I want to do a little bit more work over here and then power this back up and then actually try to adjust some of this stuff to make sure that there isn't not something else major wrong that I'm overlooking. But I felt better when I saw that the linearity was bad before I did this work, because that means I didn't screw anything. At least I didn't screw that part of it up, because I did a lot of stuff over here. I'm putting all those caps back in. Okay. My mind is elsewhere right now because I have. I'll just keep my mouth shut.